Hi guys, we're going to do our quiz for overview of transformation. So we have congruence, so it should already be done. Overview of transformations, we have 2 assignments done, and now we're going to work on this quiz. Mine says September 25th. I'm not quite sure what your date will say. Okay, so let's see what we got going on here. So you have 2 parallelograms. They want to know what's true. Parallelogram DEFG, that's the purple one, is at the pre-image because it is not the result of a transformation. Well, it looks like there was a transformation. And if there's a transformation, which is a move, there will be a pre-image and an image. Could DEFG be the image? The image is the new guy because it is the result? Sure. It said DEFG is transformed. Oh, wait, DEFG is transformed. So DEFG is the original. So if DEFG is the original, I should have read the question, guys. The original, remember, is called the pre-image, and this is called the image. So that's what we need to find. DEFG could be the pre-image because it's not result of the transformation. That could be right. Let's double check here. DEFG is the image. No, it's the pre, if it's anything. VSTU is not the pre-image, it's the image. VSU is the image because it is not the result. No, it is the top one. DEFG is the pre-image because it's not the result of the transformation, it's the one that will be transformed. Sorry, I didn't read there. This figure shows 5 points, and a point has gone to the right and up. Okay, so we're going to take a point, and we're going to go to the right, and then we're going to go up. So this is going to be the original, which is called the image, the pre-image. And then the image will be up here. So they're going to be kind of diagonal. So could point D be the image of B? Well, maybe. B could go to the right and up. That looks like it could be. So we'll click that. Could point C be the image of A? No, that would just be up or down. Could point E be the image of C? Well, C to E, it looks like, yep, that could be it. Could point D be the image of A? No, if D was the image of A, that's a down to the right, so that can't be. Could E be the image of B? Here is B. To E, went to the right and up. That could be. E could be the image of B. And could C be the image of E? C could not be the image of E because it needs to be in this other order. So those are the ones we have, just those 3. Okay, so you have 2. The shape on the left is translated to the shape on the right, which is just a slide. So what would the name of the new guy be? The name of the shape on the right is, look, they just put the prime at the end. That's not right. Remember when you call the new guy, each one gets a prime mark. It has to be in the same order. So let's see which one. The shape, it's got to be one of these bottom 2. The shape on the right would have the primes because it is the pre-image. No, the pre-image does not get the primes. The image gets the primes. So that would be this one. The shape on the left is transformed to be here. So what's happening? Well, they're using the mapping notation. That's fine. But remember, the original goes to the new guy. So the original does not get the prime. So it's one of these 2. The new guy gets the prime. It has to be in the right order. So W gets W prime, X to X prime, Y to Y prime. This graph shows a transformation of the shaded rectangle into the unshaded. So it goes from shaded to unshaded. Keisha says the transformation is called a translation, but Tegan says it's a dilation. How do you know? Well, Keisha's not quite right because it is moved, yes, but it's not the same shape. She is correct. No, we don't think she is right. It did not flip. Tegan is correct because the unshaded rectangle is smaller. I feel like that looks good. It did not turn out clockwise. That would be a rotation. What is the name of a transformation which each point is turned through a given angle? If it's turned, remember what is a turn called? That's called a rotation. But this is fun. It took a heart. Heart 1 is translated 3 units down to heart 2. Which shows this? Well, this is not right. It just wants to go 3 down. Which one is just going 3 down? That one's flipped. That one's turned. There it is. That point here, look, went 1, 2, 3 down. You just have to find one point to a new point. This point goes 1, 2, 3 down. The shaded octagon is transformed to the unshaded. So this is the original, and this is the new guy. The unshaded octagon is a reflection because it is a flip over a diagonal line. Well, could it be flipped? Let's see. If I'm here, the diagonal line, I went over 2. If I'm here, over, that's not quite right, is it? Let's see. 1.5 maybe. This one went 1.5. That kind of looks okay. How about this? Maybe it's a diagonal. Let's see what else it is. Is it a dilation? Did one get bigger than the other? No, they look the same size. Is it a horizontal translation, just a left and right slide? No. Is it a vertical translation, which is an up or down slide? No, it could be both. But it looks like it really did flip over that line or reflect over that line. That one's kind of tricky because it also looks like it was a double slide, but they didn't give us that choice. If you take a pentagon and you translate it 5 up, what would the new guy be? You just have to add in the primes. So that's the one with the prime marks in the right order. So it'll be this top one. Here's the last one. You take a triangle, you rotate it 90. What is the new guy? The new guy gets the primes in the right order. That'll be the last choice. Oops. Good job. So that is it.